Okay, I think we can start. So just to give an introduction, my name is Rishi Mara. I am the Director of Intellex Consulting Services. So this webinar is to give an introduction about the RAM system assurance topics and the courses we conduct. Then we'll have an interactive session after the presentation. So this course actually is marketed by Nikau Socio. They are our marketing agency. And yes, welcome Kavita to start.
Sorry, was that?
Yeah, so very good evening, everyone. So this is Kavita Malviya representing Intellex Consulting Services for their Railway RAM System Assurance and System Engineering courses. The course is administered and managed by Nikau Socio, and the content and other related resources are provided by Intellex Consulting Services Limited. We welcome you all for today's webinar, where we will have some discussions about application of RAMS in railways and how Intellex CPT and IRSC certified courses can help you in the better understanding and command over the subject. This conference will further be led by Railway Industry RAM expert Mr. Rishi Marathu, Dr. Mukul Verma, Ms. Madeline and Mr. Stuart Charles. The conference will cover application of RAMS and EMC in railways. Then we will discuss about Intellex courses, and in the end we will have a question and answer session. We would like to request everyone joining the webinar to keep their mics mute so that we can have uninterrupted session. For your queries, we will have we will also request, if you need to ask any question, please raise your hands. We will try to address the query, or you can send us your email at training@intellexservices.com. Now I would like to request faculties to take the lead.
Okay, we start with the introduction of each of the faculty. So if other participants who are not faculty can suppress the video, that would be helpful. Okay, my name is Rishi Marat. I have been working in RAMS for around 21 years. I've done my master's in safety and risk and reliability from Loughborough University, UK. Then I worked in Transport for London, Network Rail. Then I also worked in some of the North American projects in Dubai and in Doha. So it's all over, and I'm also doing work in India. I'll just share my screen. So the Intellex Consulting Services is the company. It's a specialist company focusing on specifically on the RAM, safety, system assurance, EMC, human factors, and all other system engineering disciplines. So this is in a nutshell about me. I'll pass it on to Madeline Hoskins to introduce herself.
Okay, thank you, Rishi. Hello, everyone. I'm Madeline Hoskins. I'm here today because I've worked a lot on the safety presentation and training for the courses. Like Rishi, I've been in the industry quite a long time, probably longer than I want to recognize sometimes, and I've got, I guess, about 30 years of experience in the engineering field doing safety and RAM engineering, and a lot of that has taken place within the rail industry. So certainly for the last 20 plus years I've been working mainly in the railways. I'm an engineer by training, so my first degree was an engineering degree. I'm a chartered engineer and also UREng, European recognised engineer. I've also got a degree in psychology, a master's degree, and I'm currently working on a PhD in condition monitoring aspects. So, like a lot of you, I'm a student for life. I think we all try and keep that going. So I'm looking forward to talking to you later on, and I'm going to hand over now to Stuart, if you don't mind.
Okay, Maddie, thank you very much indeed. My name is Stuart Charles. I started life a long time ago. I think I have the dubious honour of being one of the oldest people, well, probably the oldest on the faculty. So I started as an electronics engineer back in the 70s. And in 1980, I started working on EMC related aspects of electronic systems, started in secondary surveillance radar. And I spent 40 years in EMC, which is quite a long time, actually. That work has been on high-speed digital communication systems, secondary surveillance radar, but in the last 18 to 20 years, it's been really railway. I've worked on Crossrail, signalling systems, Bombardier trains for the new Crossrail system in London, where we've looked at signalling systems such as Tpws for safety and EMC related issues. Worked on London Underground extensively on their signalling systems and engineering rolling stock. My background is a degree in electronics and mathematics, a mixed degree, and a master's in EMC, Electromagnetic Compatibility, which was taken in 1992. I'm still training, not quite as much as Maddie, but I'm pursuing a digital signal processing course, which is a very interesting new domain of signal analysis. And that's it as a quick overview from myself. Thanks very much, and I guess I'll now pass on to Dr. Mukul.
Yeah, thank you, Stuart. I'm Dr. Mukul Verma. I started my career as a railway signal engineer and worked in Indian Railways for about 25 years. During this time, I went on deputation to IIT Delhi, where I developed electronic interlocking system and also got my PhD on that system. While in railways, I was also involved in safety certification. I was in RDSO Lucknow, and for about 7 years, I was involved in safety certification for signaling systems. And after leaving railways, for last about 15 years, I'm working as a RAMS and safety design consultant. I'm a chartered engineer of Engineering Council UK, as well as from IET India, and fellow of IRAC and IET. Thank you.
Thank you all. Okay, now let's get on to the presentation. The way it is organized is that initially we'll discuss about these topics. Safety, RAM, EMC, system engineering, all these topics. Then we discuss about the courses. So we'll try to club the some of the topics together so that one faculty can finish it together, and the EMC one we try to merge it there. And after the topic presentation and the course presentation, we have a QA session. So you can feel free to raise any queries in the chat box. So we will organize it and selectively we'll try to answer the queries. The other queries we will post it on the website on the answers as well on that. So let's make this session adding value and interesting. So I mentioned about the company. It's a UK registered system engineering consulting company. So we are specialized in the systems assurance system engineering field. So we established in 2007 and we deal with system safety, all types of work, the Excel assessment, demonstration, system safety analysis, hazard analysis and the risk acceptability. We are also in the process of getting registered as an independent safety assessor. At some point, we'll add that also would be added to this. RAM, we do the RAM analysis and designs. Any new systems you are bringing in, it needs the assurance. So we provide the RAM assurance, lifecycle costs for the asset management, all elements of RAM engineering we will do. We do the systems engineering, which is the requirements management. As for the client's perspective, that is the most important thing they should be doing, because what are the requirements and how you're going to, what you're going to get out of it, and the compliance to them. These are the things which strictly sought from the suppliers. Then system integration and electromagnetic compatibility, EMC, which Stuart is covering today. And we also do support for human factors and ergonomics. We also have a collaboration with the University of Birmingham. So we do some research support as well. We are developing some tools in Right Track, which is already in the market at the moment for the track maintenance. Then we also have a tool of FRACAS to support the FRACAS process in the projects. And we have a RCM reliability centered maintenance, which is the extension of this FRACAS to the maintenance phase.
Hello.
I'm so sorry, I am interrupting in mid. Kindly mute your mic, because we are looking for uninterrupted session. So if you need to talk, then please mute your mic. Only faculty will speak. Other rest, please. If you have any question, please raise your hand. Otherwise, drop your questions in chat box. Thank you very much.
Okay, the training, we have the appreciation course. This is the training part. We are also a member of continuing professional development body in UK. So they accredit our courses. We have this appreciation course, which is for beginners, senior managers, and all who wants to have a general idea. Then we have the module courses who want in-depth knowledge in each of these topics. Then we have certificate courses, which is an amalgamation of these module courses to have the RAM certificate and all. And advanced course is a detailed course which covers all this discipline. And this has been accredited by IRSC as well, IRSC UK. Okay, so I'm covering the system engineering part of it. So we'll just quickly go through that topic. So many of the people, they'll be new to these topics. So that's why we are covering some of the basic facts as well. And we talk about the application side as well. So what is a system? We hear it in several occasions. It can be at the product level. It can be at the where you have several components have different functions integrating, or it can be at a subsystem level, or it can be at the system level. Here is an example of a system at a railway level. Let's examine for a system which the main function is taking passengers from A to B. So it's a combination of components and actors that work in harmony. There is always an objective of the system. It's not just a group of components together. They have to work for a common objective. So it can be combined to form a larger system. So then you manage separate subsystems separately. Basically. So when if you take it passengers from A to B, you need a train, and the train is one of the complex product. So you have several elements with different functions. So when you are looking at the railway level, the whole thing is one black box. It's everything is there. So as far as the railway user operator is concerned, this is one box is getting, you would take the passengers on, and it has some functions. Whereas if you go to the rolling stock manufacturer, then you have several suppliers providing this. So there are these functions, they will allocate to each one of them, like coupler, gangway, door, each has different function. There is limitation of time, I can't go through in detail. So for taking the train from A to B, obviously you need a track. You need to run on a track, and track has its own elements, switches, route setting, and all those elements are there. Then nowadays in metros, the trains are driven by train-borne signaling. So the train is intelligent, so it controls its speed is according to the movement authority given to it. Then it opens the doors, closes the doors, all these things it can do. It can be driverless as well. Wayside signaling. Wayside signaling is look at the other trains and make sure that each train does not collide, it doesn't derail, it to take passengers safely from A to B. So that's the wayside element of it. So these interact through radio basically nowadays. Then you have train-borne communications, which has for any kind of emergencies. If you need to contact control center, you need the train-borne communications, which deliver its function through the wayside communications as well. You got radio mass antenna and all, which delivers the comms functions. Then once the passenger reach the A or B, then they need all the station system, escalator, lift, and also the safety systems like fire, life safety and all has to be there. So it's a quite complex systems you need to handle. And it need to be powered. So you need a overhead catenary system or a third rail where you power in some, or otherwise it's diesel engines, locos has to be there. Then operations also form a part of it. Actually, the human is also part of the system basically. So the operations is quite important because if the system is working in normal, then the safety is secured by the system. But if it goes to degraded, then system would say that no, I can't ensure the safety. Then it's up to the operation. So they need to have all the procedures in place to cover the emergency and the degraded operations basically. So that's quite important. Maintenance, it's also important. So all the assets should be fit for service before it should be demonstrated fit for service because it's a public utilities thing. So the public safety is dependent on the fitness of the assets. So like, for example, if the track is not correctly leveled, the train can derail. The signaling system and all, at least they are fail safe. So it will, even if it fails, it's fail safe so that it will not injure anyone. And the system is about integrating all these elements to deliver that function that taking passengers safely from A to B. So that's what the system integration, everything, all these elements has to work in harmony. So this is the definition of a system. So system engineering discipline. So the system engineering is an approach we discussed already. It is interdisciplinary. So you need to look at the functionality of asset. System has to has its own life cycles. You have different specialist branch requirements management. I briefly mentioned earlier. You have system modeling, which is to make sure that your requirement set is complete. It is just like if you before you build a house, you want to get a 3D model of the house you're going to build and make sure that you have all the elements in it. So currently there are system sophisticated models available. Then system integration is a quite important function on this.
Okay. System engineering manages complexity and fashioned around the system.
Shall we take the questions at the end because there are a few slides to go through, then we can discuss.
Interdisciplinary branch of engineering, it consists of following specialisms: the requirement management, system modeling, system integration, system safety, reliability, availability and maintainability, and electromagnetic compatibility, human factors and performance. System safety, RAM, EMC, human factors and performance are called non-functional aspects of the system.
Please? Hello. Would you mind leaving the questions till the end? And we've got a presentation we'd love to get through first, if possible. And we will try and answer as many questions as we can when we get to the end part of the presentation. So sorry to interrupt, but it is important. Otherwise, we destroy the flow of what we're trying to say.
Yes, that's right. Yeah. Okay, so one thing, a point to note that system safety, RAM, EMC, human factors, they are generally categorized as non-functional aspects. So these are attributes of the functional requirements of the system. Please. Okay, on the safety assurance, safety assurance is currently a legal requirement because you are dealing with public safety. So there are
system. Design complies with the applicable standards. Consistent, secure.
It's just reading the this one. It's coming from Okay.
Sincerely, we are requesting, please.
Okay. Okay. So design. So how do you? Yeah. Okay. How do you assure that the system is safe? First is that you make sure that the design complies with the standards. So there are defined standards, international standards are there in each discipline. So that design has to comply with them. So if you are not compliant, then you need to get a concession which is agreed by the authority. So that is the first level of safety. They make sure that design is compliant. Then you have competent people to develop this design, and checking, testing, everything is done by competent personnel. So that is the second level. So all these elements has to be there. Then only you can say that it is safe. Then products approved for use. So any products in the railway, there it should go through a approval process. No one should be allowed to bring something directly into the passenger railway and test on the passengers. So it should have a precursor to it. There are lab trials to be done. Then you are done the non-passenger lines. Then less busy areas. So any safety critical product has to go through this approval process before you put into place. So that is another mandatory thing. Then you need to demonstrate that any risk, safety risk arising from it, because each project is unique. So you cannot say that every project it has the same risk. No, even there are location specific hazards, then asset specific hazards. So all these things need to be identified, and you demonstrate that it is at an acceptable level. Then the operators, maintainers are trained, and any operational risks are mitigated. So this is last.
It is originated from the asset failures have been minimized to a level.
Yeah, to an extent, yes. Then
operators, maintainers are trained, and any operational risks are mitigated. The asset failures have been minimized to an acceptable level. Operator, maintainers are trained, and any risks are mitigated.
Yeah, Kavita, we can try to mute all, then I will unmute myself.
Is it your computer?
Okay, so I can, yeah, so now it should be fine. Then the changes introduced to do not interfere electromagnetically with other existing infrastructure. So this is the EMC element of it. Then it does not endanger the neighboring system. So all these elements has to be part of the safety assurance, basically. Then only it can be said, yeah, this system is safe for use in the railway. So this is the system life cycle. So I would invite Maddie to unmute herself and just go through the life cycle. Oh, you can unmute.
I'm unmuted. That's fine.
Yeah,
Thank
okay.
you. Thank you,
Yeah.
Right. The life cycle we've put here is the one taken from EN 50126. Now, obviously, there are lots of different life cycles that you can apply to product development, but this one is specifically written for considering RAM and safety issues. And again, because it's part of the Euro norm standards, which are internationally recognized and used throughout the world, it's quite a good one to reference back to all the time. On our course, we actually use this to consider what work needs to be done at specific parts of the life cycle, and indeed what documentation needs to be produced and what needs to be in that documentation. The life cycle, as you can see here, is essentially split into three areas. The first being risk assessment. Now, whenever we do any kind of safety engineering, it starts with us identifying hazards and working out what to do with them. At the end of this, you come up with effectively safety requirements and RAM requirements when you look at it from that point of view. We then feed that in to the design of the architecture and apportion system requirements, including reliability requirements and things like that for the various systems and subsystems. Now, all that's going on the left-hand side, the downward part of the V shape that you can see there. So that's on the design side and design development. And then we move into the upward part of the life cycle curve, the path that goes up from 7 onwards. And we start making the equipment and the systems, integrating it, validating that what we're trying to build, what we've specified, is actually being built and does exactly as we think it does. And we go on to do the system acceptance to making sure that it complies with all the requirements that we originally thought it was going to do. The final phase, operation, maintenance and decommissioning. Within that, obviously, you've got your operational lifetime of the equipment. Once it's been built, it's put into operation. During that time, there may still be issues that need to be assessed, and we feed those back in and do risk assessment and assessment of improvements and everything else prior to making any modifications in a controlled way. The last stage of any system, decommissioning. It's true that a lot of the time we only give a little bit of thought to decommissioning, because sometimes it's going to happen 20 or 30 years in the future. If you're from the civils field, for example, you will really be thinking of how structures can be decommissioned safely a long time in the future. That, in a nutshell, is the system life cycle, and as I said, we use that quite a lot as a reference point in the course, and we will go through that in quite a lot more detail. Thank you, Rishi.
Thanks, Vinny. Okay, next is just a glimpse on RAM assurance. Before getting into the RAM assurance, one of the fundamental of RAM is the bathtub curve. So every project starts at this point where the infant, we call it infant mortality. So there could be some teething issues, and especially when the systems are quite sophisticated, you can have a lot of software issues, systematic issues, and also this will be the initial phase where we need to have a proper root cause analysis and fixing of these failures. So that's called the process is called fracas. So we have a tool to manage the workflow of the fracas process as well, and all the RAM, all the RAM equations. It doesn't hold good here. It's for the next part when you have a normal life. Where is it? Sorry. In the normal life, you have a constant failure rate. That's the phase where all our Mtbf equations, like operating hours by failure is equal to Mtbf, all these equations hold good. Whereas in the infant mortality phase and also at the wear out phase, we cannot strictly use those equations. So here normally each project has to cover it through the warranty. Even if you're buying a car, you have a warranty period, because any kind of systematic issues, the suppliers, the OEM is responsible for it, and they need to cover with the warranty period. Sometimes the operational disruption is too high, so some of the operators, they put some incentive clauses that if you operate without disruption, this is your incentive, or if you have failures, this is the penalty would be there. So all these kind of clauses would apply. So every time you need to, the infrastructure owners try to encourage to minimize this area and maximize this normal life. So the earliest you get there, that's where you can put it into service. Basically, you don't want to put all the passengers through this curve, basically. So you will have extensive trials and all before you go there. Then the end of life wear out. And normally you start planning the new system before you climb here, because many of the components become obsolete and you may not have enough spare. The spares will be consumed so fast when you're reaching here. Okay, so what in the RAM assurance of the system is that the system is capable of meeting RAM targets and fulfill RAM requirements. That's one important thing to note, that RAM targets is driven only by the contract, not by the standards, unless it has safety impact in it. Because making profit is not in the scope of the standard. Standard is only to ensure public safety. So just comply with the standard is not actually good enough. Like 50126, these are all process standards. You need to have specific RAM quantitative targets and qualitative requirements to meet that. And this is generally the single point failures. It need to be minimized. The minimize is a quite loaded term. See, you can always minimize it just making it redundant. But bear in mind that when you make it redundant, whoever is going to buy this, they have to maintain both these assets throughout its life, and that is double life cycle cost. So unless that failure it is mitigated is quite serious, then only you make it redundant. Otherwise, you work around with operational support and all that to minimize the disruption. Then you have built-in mitigation so that it fails safe and it has some degraded mode so that you can recover those kind of things so that you minimize the impact on the service. Then it is maintainable. Yeah, you don't want something installed where it's very difficult to access or it is not easily maintainable. It's a problem. Then you should have adequate maintenance support for it. So you should have the spares, especially for this electronic equipment and all. It can get obsolete quite soon, and you may not get the spare part. Then it's a big problem, and it has an acceptable life cycle cost. Having said that, this normal useful life is not the same product will go throughout its life. What would normally happen is that there are several upgrades happen for that product when some of the because due to obsolescence or due to software update. So it will be like it'll have a small butter curve for every midlife upgrade happening basically. So that is in practice. So that's what in operation and maintenance also in the new standard 50126 you need to have a fracas operating during the operational phase as well. Fracas is not just maintenance. It's about root cause analysis and identifying the defects which give rise to several failures. That's the process of fracas. So many people just confuse it with just maintenance. Yeah, this is the RAM overview. Mukul, you can just quickly.
I will take this. In the RAM module, we will to start with, we will understand what is reliability, availability, all the parameters. It is very important to understand the parameters and their quantitative representation, because if you don't have the idea of how quantitative representation can be made, then you can only say, I want a very reliable, very safe system, and the supplier will give you something saying, yes, it is very reliable. So there should be a mathematical representation in quantitative terms for all the parameters that we hear in our everyday life, like Mtbf, Mttr, failure rate. So we will understand how these quantitative representation is done for different parameters. Of course, they are probabilistic in nature, meaning suppose you get an equipment of say Mtbf of 5,000 hours, but there is still a probability that it will fail within 1 hour. So it all depends. Mtbf only gives the idea or gives you a term by which you can calculate the probability of failure in different time periods. Then we will also see mathematical modeling. Well, when you are designing a system, before design, if you want to, before implementation, if you want to know what will be the reliability or availability or all the parameters. So we will see some modeling techniques. Sorry. So we will see a reliability block diagram, fault tree analysis, Markov model. These are the tools by which you can do reliability calculation and predict the reliability from the respective values of the components. We will also see fault tolerance. Fault tolerance is the property of the system by which it can work in presence of some faults and giving you time to correct that fault. So we will see different types of fault tolerance, hardware, software, because these are used to attain the required reliability and safety. We will also see the importance of apportionment of the RAM parameters, because suppose you are building a system, you have got some idea that, okay, I should have this much reliability, this much availability. But when you are ordering for the subsystems, you should know what I should specify. What should be the parameters, say reliability or availability of the components, so that when I integrate different components, I get the desired value of reliability as well as safety. So these are some of the important points that we will cover in the RAM module. Back to Rishi.
Okay. Okay. This is just on the system assurance. See, system assurance, people think that it is just an amalgamation of RAM and safety. No, it is about the process to deliver confidence in the project outcome. That is, it's always about the system assurance is about the identification of risks as the project develops. So you identify the risk, it is cheaper to mitigate it and lesser the consequences. The later you identify the risk, it becomes a bigger issue and it's expensive, and cost and time implications are more. So it is delivered at each stage. You may have come across these gate reviews in some of the projects if we are working on it. So the gate reviews is about looking back and see at each stage what are the work which has not been completed, or what are the risks which has not been mitigated, whether we can work with that risk in the next stage or you need to resolve it there. So normally any kind of safety risks and all, you would want to fix it then and there itself before you progress. So that will be a no-go gate basically. As I said, it's a review of compliance and risk. That is what the system assurance process is about. The system assurance reviews recommend whether the project is progressed. That's what I mentioned already. Okay, next we go to EMC. We are also running a overview of EMC course. People who wants to know about the EMC. So I'll invite Stuart to cover this slide.
Yeah, thank you very much, Rishi. Stuart Charles here. So a very quick overview on EMC. What's it all about? It isn't taught in many universities. In fact, a lot of people go through in engineering and don't come across EMC. So electromagnetic compatibility. Very quickly summarized here. We are concerned about protecting the radio spectrum. I've got a mobile phone here. If there's a lot of interference in a station or on a train, I may not be able to receive a signal. The signal strength received by a mobile is very, very low. It's in millionths of a volt, certainly less than a millivolt. Okay, we also need to ensure that copper cables, power cables in any system do not carry interference. Always use the analogy, this is a dipole antenna, one I use when I'm sometimes teaching courses face to face. And you can ask, what's the difference between a dipole antenna, which looks like two pieces of wire, and a copper cable, which again is a piece of wire? So really what we're saying is every cable in an installation could give us an EMC problem, and that's why we need to understand in depth what the threats from EMC are. Also absolutely critical, especially on the railway, we must protect safety critical systems from failing if there's a lot of interference about. I mentioned TPWS, Train Protection Warning System. That system, which is now fitted to a lot of trains on the 25 kV network, it's there to protect the train from overspeed systems and also possibly failing to slow when it comes near to a red signal. These are absolutely crucial areas where if EMC or interference, electromagnetic interference, upsets a system, we could have a catastrophe. So difficult subject. We think in the course, which we're going to talk about very shortly, we've covered it so you don't have to use any mathematics. Most people don't like too much maths, some do, but in this EMC course, we've kind of removed the maths from all aspects, apart from a couple of equations. The standards, very briefly, there's a whole host of railway standards. If you're working on a station, there's even more, because you'll have a ticket office with laptops, you'll have basically industrial sort of building management systems, many standards. These are the key ones from a rolling stock and track point of view. There's signalling. We have to test the train, so we're interested in putting an aerial up. You can see that aerial at the bottom of the screen, called a log periodic. No big deal, that's just the name of it. It measures the emissions, in this case from a train. It's placed 10 meters away. We need to ensure the train is electromagnetically quiet. Equipment on the train, rolling stock equipment, that has to meet another standard, 5121-3-2. Power supplies, yet another standard. All the tests are similar in these EMC standards, but there are different levels of intensity. Communications and signaling probably has one of the highest test levels because of the criticality of the system. Okay, I think we can move to the next slide now, Rishi, if that's okay.
Okay. So just for continuity, next we start with the courses. So just for continuity, because Stuart has been presenting, so we start with the EMC course. So
thanks, Rishi. Right, so very quick overview of the course. This course has been written for engineers, technicians, electricians, you could say, certainly management, project engineers, senior management, and the whole thrust of the course is to teach you about EMC in a non-mathematical way. We can go into maths, should you wish, but that's not in the fundamentals of the course. We try and teach the concepts of EMC so it can be understood by everybody who is not an EMC engineer. The EMC engineer, and I say I've been in EMC 40 years, usually talks in a strange language with strange terms. And as I said before, this is not taught in a university or college course, and it's very difficult to pick up and understand what your EMC engineer is actually saying. And this is incredibly important, you know, from contracts. So let's look very briefly through the course. I'll try and move through this fairly quickly because this is a small part of Intellect's overall course delivery. So why is EMC important? Well, regulations, you have to meet EMC regulations, mandatory. Contractual requirements. Now, if you've got an EMC requirement, and this happens a lot in a contract, people often ignore it, or they may not ignore it, but it gets put on the back burner. I don't really understand what that's saying. That could be quite an issue, because if your contract requires you to deliver some EMC deliverables, some reports, and you haven't fully understood what that requirement is, that could be a major issue contractually for your company. Safety. This course is a lot about safety, and you're going to hear that from some of the other speakers. Tpws, I mentioned, Train Protection Warning System. Very briefly, I was working on a Crossrail project, and they were getting false signals. The Tpws system is basically two metal loops in a track which have a current pass through them. They produce a magnetic field. The train has a receiver, and you can communicate track to train. There was an issue where they were getting a wrong signal at the Tpws frequency, and it was believed to be due to EMC produced by a TI-21 track circuit. That's another story, and possibly discussed in the course. So basically safety, we mustn't get interference and get false signals. Reliability, we want reliable systems. We do not want them to be upset by interference. Supplier quality. It's a very interesting story. The head of London Underground once told me they had a passenger display and it flickered. It wasn't the quality was not good. And the issue they had was a psychological one. Would people feel happy that signalling system was good if the displays didn't work very well? So this whole integrated, holistic approach to EMC is important. Finally, there's power quality. Power quality is very important. If you've got tunnel vent fans, you could upset the power supply and affect other apparatus. That's a sort of quick overview of number one. Let us move to, very quickly, why is the EMI environment, electromagnetic interference environment, really harsh on the railway? Well, we've got 25 kV systems, long cables. We get sparking with the catenary. We've got communication signals and signal cables running in parallel to the catenary. They could pick up interference. We get shoe bounce, London Underground. I don't know if anybody's been on the Underground, but it runs on a 630 volt system, and my goodness, there's a lot of arcing, and the signaling's carried out in the tracks, so it's subjected to this electromagnetic interference. Signaling circuits in running rails can be an issue. And then there's touch voltage. These high voltages on 25 kV can actually induce, via transformer action, high voltages, and people can get shocks. Okay, number 3, very important. All I'll say here briefly is if you don't understand your EMC engineer, you could miss things in terms of, has he delivered what you're expecting? What are you expecting him to deliver? You may not have a dedicated EMC engineer. You may have an experienced senior electrical engineer, but everybody needs to understand the terminology. Otherwise, we could run into all sorts of issues. How's EMI generated? We do talk on the course of all the sources of EMI. For example, lightning, that's one obvious one. Radio transmitters, that's another fairly obvious one, but there are others, and we talk about what are the sources of EMI. EMC standards, unfortunately, there are many standards. I have to deal with probably about 30. I can't memorize them all, but it's good to know which ones you should be using in a railway application. We mentioned some for trackside and rolling stock, but how about in a station? Can you use commercial apparatus, in a railway station? I mean, it's a fair question. We cover that in the course, and the answer is yes, but it depends where it's positioned with relative to the running rails and the train, the locomotive. Okay, so let's have a look. We've got standards, coupling mechanisms. We do talk in the course about how this interference couples, so you understand, do I have to keep cables apart? If so, how far do I need to keep them apart? So we cover all these coupling mechanisms. We give you examples now. I have just worked on a project, a major project in London. I cannot tell you the name. It had a major issue with a variable speed drive. This variable speed drive actually drove a tunnel vent fan, which is important for ventilation and also smoke extract. Now, they had a problem when it was commissioned, and Madeline mentioned about how key commissioning is. They had a problem when it was commissioned, and nobody ever tried two systems together. They suddenly found they interfered. It was handover time. The project was delayed 9 months, and I think the costs involved were probably hundreds of thousands of pounds. Not a good situation. It doesn't happen that much if you've got good EMC control, but if you do deal, and we talk a lot about variable speed drives in the course, how to contain the EMI. If you do deal with large devices like variable speed drives, you can find you get a lot of interference on a lot of other areas. Okay, EM waves and shielding. We talk about very basically, what does an electromagnetic wave look like? I'm not being stupid there. If you've got a picture in your mind of what a wave looks like, you can understand how it propagates, and can it get into slots on boxes and upset things, and how do you shield a box, an electronics box? Do you need to shield a box? We talk about that, not in any depth in terms of mathematics, but just in basic understanding of concepts. Harmonics. Some of you may have covered the terrible topic of Fourier analysis, which is highly mathematical, and it talks about harmonics. Basically, this is very much like baking a cake and putting ingredients in. Every waveform can be simulated by sine waves, adding together the right sine waves. Why is this important? Well, if you have power systems, they produce harmonics, frequencies that are above the 50 hertz. You may have 150, 250. These harmonics They don't contribute to real power, but they do cause interference. Your network operator, the DNO, may say, and this is certainly true in Europe, you cannot contaminate the main supply. What does that mean? We look at this, these sine waves that are generated by power equipment and also computing equipment in a non-mathematical way. This affects power quality, number 10, and we can find that as we had on a particular station on Crossrail, we found that we were contaminating the power system that other users at other stations and other industrial users were using. We had to put in filters, what are known as active harmonic filters, in the whole Crossrail installation on every station, many hundreds of thousands of pounds, to control the harmonic noise that was contaminating the network operators' 415 volt three-phase supply. EMC zoning, we talked very briefly about, can you use commercial kit on a train? The answer really is no there, but could you use it in a station? And the answer is yes, if you follow certain separation rules. We call that electromagnetic compatibility zoning. Keep commercial equipment basically away from industrial equipment, and industrial equipment a little way away from equipment that has to meet these really tough EMC standards. 12, variable speed drives, one of my favorite topics. These can be a major EMI threat. We have a complete section dedicated to this. How do you incorporate variable speed drives? So these could be for tunnel vent fans, they could be for ventilation systems. You'll find that they're used extensively throughout the railway system. How do you design them in from an installation standpoint so we don't get interference? Lastly of all, you can do all the right things in terms of EMC design. You're working closely with your EMC engineer, should you have an EMC engineer, or you may take that on yourself if you're a good electrical engineer and you wish to work in the EMC domain. You've got to prove, you've got to provide the assurance, the EMC assurance, that your new rolling stock doesn't upset signaling, that your station will function without any degradation due to electromagnetic interference. You're going to have to produce documentation that proves you have a robust system with respect to EMC. How do you do that? We discuss what the deliverables are and how you ensure that what you are delivering proves you have an EMC robust system. So this, going very briefly across the course, it is taught in a non-mathematical way. Rishi said it's about 4.5 hours online. It is CPD certified. And we do have, because EMC is a tough topic if you've not had any background in it, so we do have live support sessions where you can throw questions at me. Hopefully I'll be able to answer them straight away. If not, you'll get an email very shortly afterwards. There is an online test, but as I say, the course is structured for non-EMC people, and we believe it's pitched at the level such as engineers and managers, project engineers, project management, senior management, should they wish to attend, can easily assimilate the key aspects of EMC. So thank you very much. Back to you, Rishi. I think that's
okay,
short.
Thanks, Stuart. Yeah. So we'll go through the other parts of the courses. So just to give an overall picture of all the courses. So what we just talked about is the overview EMC course, which falls in our the course structure. So we have an appreciation course at the mainly for senior managers, project managers. Everyone needs to understand system assurance, RAM, safety, because these are all will cost money in a project. Basically, for example, if you don't effectively manage a fracas, there could be a lot of penalties and a lot of failures attributed to the supplier, which is not easy to argue at unless you have a proper fracas process. So everyone needs to understand. So, and it will give a CPD certificate. Currently, this is offered in a corporate training level at the moment, because if there's a group, then we will offer it's a live session 2 days. Then we have the detailed sessions. Each of these topics, system safety, RAM, system assurance, system engineering. These are available in module level. So if you are a safety engineer, not practice RAM enough, so if you want to gain more knowledge in RAM, you can do these module courses. Or independently, you can complete all these module courses. You can get a certificate for the RAMS and system engineering. This is a detailed level. Then we have a structured course, RAM certificate courses, which is 40 hours online tutorials. It has safety module, RAM module, and some chapters of system engineering and system assurance. So this mainly for the discipline engineers, RAMS engineers, or operation and maintenance, because currently the standards cover all these disciplines. So if you have a understanding of RAM and safety, you would be able to effectively contribute in a project in these aspects. When you get a document to review, you would be able to review this correctly instead of just looking at a system description. Then the RAMS, then there is an online certificate. You get a CPD accredited certificate, basically. And there is this advanced course. This is again for the people who want to do RAMS, and this is an accredited by CPD as well as the IRSC. This is have this is the advanced course where you will have a case study live also for a week, and that is done by all the 3 faculty, and there is a tutor assessment afterwards. So this is if you want to do a work as a RAMS engineer as a practitioner, this will give you a solid foundation and get a good understanding of the course of these topics, basically. So the EMC we already talked about. So this is the overall structure of the courses we are offering. So I mentioned about the RAM certificate very briefly. It has safety module in detail, RAM module, and selected chapters in system engineering, which is mainly the system lifecycle, which is essential, and also the system engineering principles. And it has the assurance regimes. Different types of assurance regimes are covered, and how assurance is managed. It is a written exam or a coursework would be done to get, then you get a CPD certificate course. This is the advanced course. We talked about the certificate course, which is detail of each module you cover, and the written exam you get the certificate course. And once you do a case study, you get the advanced course. This case study is a live, so it is like a building block. You complete all these modules online, and then this is the 1 week live lecture. Then you get these advanced courses. This is briefly on the courses management. The strategy, it's a no frills approach to keep the affordability of the course. So the emphasis is on the technical content, and we are getting this course certification with CPD. It is done. IRSC is one of the courses done. Advanced. Then University of Birmingham is the next step. We want to get accredited through the university. We already have a collaboration with the university, but the courses still need to be accredited. Then it's an online course. Each module is divided into chapters. So the way it is structured is that it's a recorded lecture with animated slides, so that it keeps you focused. You can do it in your own pace, and there are overall target dates you need to comply with, and there are worked out examples and exercises. And obviously nothing can substitute live sessions, because that spontaneous element comes only in live sessions. So we have multiple live sessions in small groups. So you have specific queries when you go through the course material, we'll discuss, and all these discussion will also be recorded and published in the website as well. So there is a whole lot of learning area which has a lot of resources which you can utilize. Then there will be an online test. These are coming from a random pool of tests. So each participant would be getting a different set of questions. So there is an 80% mark. That's 20% is mainly meant for some careless mistakes, because you need to understand the whole topic. You cannot just go, oh, I don't do safety case. Then you're not a safety engineer. You need to understand all the topics, basically. The written exam and coursework. So if you know, the written exam, open book exam. So we need you to do that exam or coursework. It will be given a period. Then you submit it to us. If it is an exam, then we have a camera and we have the scan copies sent to us. Then it's a 60% for the pass. Then case study. This is for the advanced course. This is a live session for 40 hours. It's analyzed the typical application of a safety critical project like CBTC. Then we have supervised workshops, how to conduct a hazard workshop, how to do a FMEA, how to do root cause analysis. All these elements we have practical examples. Then typical deliverables. What are the issues you should consider when you prepare all these system assurance deliverables? So these are mainly meant for someone who wants to make a career in RAMS or someone who wants to have a deep knowledge in RAMS. So we try to have a web event to award the certificate. It's all accredited by the CPD, and we'll award it at the end of the course. So I'll briefly speak about the system engineering disciplines. So this is a bit. So let me just get through all. So the system engineering module is covered by me. So we have the outline of the system engineering principles, which covers all the topics of all the principles. Then generally on what is the system, a sample you're seen at the moment, system boundaries. So it gives you a good idea of the system engineering principle. Then system life cycle is a quite important part, which is covered in safety as well as system engineering. And also the Kavita, can you please mute all? Then unmute myself. Okay. Then the black box analysis. Black box is an important concept. That is the level of detail you would like to analyze when you do the system. Then these disciplines we just briefly talked about. VNV we cover in detail. Then safety, RAM, human factors. This module in a nutshell, it gives you a basic idea of all the elements of system engineering. And finally, to the life cycle cost is also an important element of the system engineering. So we cover the life cycle cost also in this. So I'm covering this module specifically. So it's around 12 hours. And you get a CPD module certification, and it's the same pattern as all other modules, basically. Okay, this is the system safety module. Maddie, you want to briefly talk about this?
You are muted, Maddie.
Maddie, you need to unmute yourself. Yeah.
No, I've just unmuted myself. Apologies for that. Yes, thank you for putting all those up. So the system safety module, as we've got here, we've tried to cover a whole range of aspects about analysing safety, managing safety, and practically implementing it within projects. Now, when I talked about the life cycle earlier, the first thing I said was one of the things you have to do in considering safety risk is you have to know what your hazards are. So our first module looks at hazards, how we identify hazards, what hazards are, and more importantly, what risk is, because there's a lot of confusion in people about what risk is in the engineering environment. A lot of people use hazards and risks interchangeably. They'll talk about something being risky. They'll talk about that's a risk. Well, we separate that. We make very clear distinctions on this course. And that's the first module, and the basis for all the safety work is understanding hazard analysis and risk analysis. We look at how to apply this at different levels in the second module, systems and product safety assessments, SIL levels. We get a lot of questions about safety integrity levels. We do look at this on the course, how to consider the levels you need to achieve safety, and how to fit that in with your overall safety assessments. Again, when I was looking at the life cycle, I talked about Emc standards and Euro norms. Connected with that also are common safety methods. Now, on one of the other modules, we go into common safety methods in a lot of detail. The standards we are principally looking at EN 50126, 128, 129, and they cover the safety elements and safety cases and all the aspects that really we need defined in order to do safety work properly. Now, in the fourth module set, and I'll call it a module set because we look at each one of these in separate modules, we look at the actual techniques that we'll be applying. So the practical ways to manage a hazard log or hazard record. Failure modes, effects and criticality analysis, FAMICA. Fault tree analysis. Again, we'll look at doing some small amounts of fault tree analysis so you understand how the technique is applied and some of the good practices that you should be using when you're building your own fault trees. Same with event tree analysis. We look at how to define safety targets and do compliance. We then, as I mentioned, take a more detailed look at the common safety method. Now again, the common safety method starts, as you can guess, with proper hazard analysis, identifying your hazards and managing the risk. And that will be a constant theme through all of this. The safety case that we then look at is all about showing evidence, providing the evidence and the argument that your new product or your change to the railway infrastructure is a safe one. We talk about engaging independent safety assessors. Now, Rishi knows all about this. He works as an independent safety assessor a lot of the time.
Yeah.
And we've used that information in this module because it's very first-hand, all of this. And safety reviews by statutory bodies. And finally, we'll take a look at all the different system safety deliverables in the context of that EN 50126 life cycle that we showed earlier. So taking all in all, when you do this, you will look at the management principles, you will look at the techniques, and you will understand, hopefully, how it all fits together. Now, like Stuart, I've tried to keep the maths very light in this course. And I like to say that although we do a little bit of probability analysis, probabilities are all about numbers between 0 and 1. Everyone can count to 1. That's what I say. So the mathematics isn't too complicated, I hope. And that's basically an overview description of what you'll be covering in the the system safety module. Rishi, back to you.
Yeah. Okay, we'll just go through the RAM engineering module quickly. Mukul, you can cover this part.
Yeah. Thank you, Rishi. In the RAM module, we will see, we'll first go through the mathematics. As I told you earlier, all the parameters are probabilistic in nature. So we will start with probability theory, because if you analyze the parameters and the relationship between them, then you must know the probability theory. Then we will go to Venn diagram and Boolean algebra. Boolean algebra will be useful in fault tree analysis. Then we will go to matrix analysis. Matrix will be used for Markov analysis. That is one of the types of modeling. Then we will go to RAM basics, where we will see the detailed explanation of reliability and other parameters. Also, we will establish certain relationships between the parameters. We will go to different fail distribution methods for reliability, like constant failure rate, log normal, and we'll just touch upon some of them and study more about the constant failure rate module. Then in chapter 3, we will see RAM modeling. We will also do some exercises. RAM modeling, as I said earlier, is used to predict the reliability at the design stage itself. So we will see a reliability block diagram, fault tree analysis, Markov method. Then we will go to fault tolerance. This I have already covered, that we will see different types of redundancy, like hardware redundancy, software redundancy, to achieve the desired level of reliability and safety. Then we will deal with FEMICA, that is failure mode effect and criticality analysis. We will also see software reliability, because as you are aware, at the time of installation, there are a lot of bugs which is required to be fixed in the software, and that is important. Then we will go to RAM apportionment. As I talked earlier, you need to apportion your requirement to different subsystems. Then you can specify these requirements to the vendors who are supplying the subsystems, and ensure that when all the subsystems are integrated, you will get the desired reliability and safety level. Duration of this module is 17 hours. This is a CPD approved module. Of course, there will be some live sessions, as Rishi said. I will be the main contributor for this, and some of the chapters will be taken by Rishi. So that's about the RAM module. Rishi, you would like to continue now?
Yeah, thanks. Thanks, Mukul. Okay, we'll just now talk about the system assurance module. Let me just remove the animations so that we don't have time to explain one by one. So okay, so it consists of essentially two parts. First part is the process. There are different types of assurance process you would find in the project, like risk-based assurance, self-assurance, and progressive assurance. I mean, these are different methods. So we will give you examples and how this is implemented, what is advantage, disadvantage, which type of project would require this type of assurance. So for example, self-assurance is just one supplier is actually giving something to the railway and say, yeah, it's all good, you just carry on. In some cases, that's okay. Basically, for example, during the maintenance phase, every time they do the upgrade, you are not going to start another project for a product upgrade. So that is assured by the supplier itself, and their process is already certified by external bodies. So, I mean, that's just an example. So we cover all these kind of processes. Then the gate reviews, how the gate reviews is conducted and what are the elements you should look at. And there are these issues, management, the risk, how you identify the project risk as managed. So all these elements are covered in this assurance management. So this is the assurance process. Second is the assurance attitude. I don't think anyone actually has covered this particular topic. It is not as preachy as it looks. It is to develop the right kind of attitude in everyone. So what I used is, I used from my own experience, one of the project where it started and the supplier, the reviewer and the client, everyone started fighting each other and it became a disaster. Then how they turned around by successful collaboration and put in place proper assurance process in place, and they have delivered another line so very successfully. That even mitigated all the bad reputation they gathered from the first line. So it's a quite interesting case study. So I'm trying to home in the point that why is the right type of attitude is important in the project, basically. So it's not a extensive module. The same structure you have online, then you got it's all CPD certified basically, and there's an online test and 80% minimum to pass. We also do the appreciation course. This is carried out in 2 days of 16 hours. So it gives a overview of each of these elements, 16-hour live session. So it has a system engineering concepts covering 3 hours first half. Then the system safety is the maximum. It covered 5 hours. This is meant for the senior management or people who are not familiar with this area. It gives you an overall idea in 2 days time. And RAM concepts, then the system assurance process, attitude. Then we have a small test as well, and you get a certificate. This is currently we are doing only for the corporate training, not for individuals. Okay, so that's the presentation we wanted to deliver. Now it's make it a bit more interactive. So we have received some queries before this during the registration. People have logged in. So I've selected some of the common general queries so that it will be useful for everyone. Mr. Unnikrishnan Kambaran from RTA Dubai is asked about the role of system assurance, RAMS, and functional safety in specific rail subsystem such as rolling stock, rail signaling and train control, rail system, etc. So this this is a quite general topic. So this is exactly we cover in our courses basically. So in the varying level of depth. So if it is in the appreciation, it is spans and explained about this role, why it is important. So there are, as I mentioned, there are legal requirements. Legally, you cannot bring anything into service without going through the system assurance process and safety process. Safety is a legal requirement. RAM, yes, if it is not related with safety, it is by the client, although it is driven by the contract. Then the system engineering requirements VNB, it's all to demonstrate that you have delivered the way what the client is asking for, basically. So that's so the project has to be managed through a proper V cycle. So this is quite important that everyone should have an understanding of these concepts. Then the next one, Mukul, you can read forward because you have been in the signaling, basically. Yeah.
Yes. Thank you, Rishi. The next question is from Mr. Muhammad Abdul Rahman from JMD Rail Tech. The question is, how are RAMs assured in signaling design? Well, in signaling design, reliability is normally achieved by using hot standby. Normally, we use a hot standby for all signaling systems. In this course, as I said earlier, we will study various ways in which the standby, or say it can be a total hot standby, or it can be just a standby. So we will see all these things in this course. Then safety of signaling system. Yes, most of the signaling systems are directly related to train safety, train operation safety. Therefore, they are at safety integrity level 4. We will study how do you determine the safety level required by the signaling system. See, safety costs money, so we should not unnecessarily assign SIL4 to all the systems, all the functions of the systems. For example, in signaling system, the panel operation or ATS is at SIL2, whereas other functions which check the command that you give, that is at SIL4. So we will study how to determine the SIL level. Safety, of course, has a quantitative and qualitative requirements, both to be met to claim the SIL4 level or for any safety level. Reliability is also important for safety, because when the equipment fails, all the responsibility of ensuring safety comes on human operator. and human operator operates at a much lower level of safety than the equipment. Therefore, there is a risk when the system fails. Back to you, Rishi.
Yeah, okay. Yeah, the next one is from Ala Khalifa from RATP. It's a quite interesting. RAMS added value to the company. Yes, as I mentioned, the safety is legal. Legally, you have to oblige. Otherwise, there are several severe penalty measures if there is an accident or something happens, and if you and that cause has been shown that you're not operated it correctly or you're not delivered it correctly, this can change the supplier even beyond the warranty period. The safety issues. RAM is mainly your bottom line. See, your availability of the railway brings revenue. So if your railway is shut down, people are not going to pay, and many of the countries you have to refund the passengers all the fare and even the compensate in some cases. So RAM is quite important to get the bottom line to the profit of the company. Fracas, yes, as I mentioned, every system has a teething time to get into. All the teething troubles need to be resolved and get into the normal steady state. So there the fracas would help that during the normally in the contracts you have the defect liability period. So in the defect liability period, you will be able to, I mean, the supplier is obliged to mitigate all the defects and make sure that you reach the steady state within that period. So that's where the fracas is important, and it's a workflow. Initially you capture all the failures, then you look at the pattern of the failures to identify defects. Then you do the root cause analysis workshop for the defects. Then there is a fracas review board when you look at the root cause, then the corrective action and make sure that it's the right thing to do. Then you have a change control process, which is another process where when you change an asset, it has to be controlled. Then you monitor whether your changes actually remove that defect or not for a period of 6 months or so. Then only you close that. So this is a workflow as per the 50126. So we already have a tool to manage the workflow and have an effective fracas in place, and how you monitor the fracas as well. So the RCA root cause analysis, one example which Stuart briefly mentioned, there was an issue in one of the projects which both of us were working. One of the new track circuits were failing. It is running on the national rail network, where the metro also run on the same network. And finally, the root cause has been analyzed and found out that the dampness of the track bed was causing the track circuit to fail. It has nothing to do with the component failure. So people doing maintenance, it disrupts the service every time, and after a few days it again fails. And especially in London, it rains quite often. There is no monsoon or it can rain anytime. So the dampness, and so once that they have improved the drainage, replaced the track bed, that problem has gone away. So that's the kind of root cause analysis we are actually talking about. Then we are talking about the Edwin Martinez would like to know the RAMS applied to a rigid catenary. Yes, it's a quite interesting question, because RAMS is generally not to that level if the equipment is passive. So even though the rigid catenary, there is no moving equipment, it's a piece of metal basically. So what the type of RAM you would do? If it is a moving equipment or an electronic cards and all, you can have random failures. So here also this rigid catenary, it can develop some defects over a period of time. The only thing is that the prediction is not much value unless you have in-service data. Then the life cycle cost is quite important basically, and how frequently you do the inspection of this catenary, like ultrasonic inspection and those kind of inspection. So those are the elements you determine the life cycle cost, what is the level of maintenance inspection required. So all this will be unearthed by RAM work. Safety, obviously, the safety has to be there. That's a legal requirement on this. The next is, you can take it, Mukul. It's on the RAMS apportionment. You talked about.
Yeah, I've already talked about the RAM parameters that we are going to discuss and how they will be represented in a quantitative manner. And for safety, Madeline has already talked. We will discuss about acceptable risk, then safety integrity levels 1 to 4, and various quantitative and qualitative requirements that are required to be met to claim the safety level. So these are the topics. I mean, all the parameters will be discussed. Yeah, back to you, Rishi.
Yeah, okay. So the next is on the Suhas Kamath from Aegis France. So RAMS inclusion in every method statement of construction is mandatory. So here actually we are interpreting this question as the method statement during the operational phase of the railway. The construction phase is covered by the. Maddy, you can maybe elaborate on that safety element part.
And as Rishi said, I think by this, I understand you mean the process of ensuring that RAMS is considered properly before a change is made to the metro system. Now, we've mentioned here, Rishi, at the start of this, that safety is a legal requirement. We always have to consider it. But think about how important reliability is too. If a failure of a railway system, particularly when it's underground system, the metro, can lead to people being stranded and large numbers of people, that becomes a safety issue in itself. So, yes, we do have to consider we perform hazard identification and risk assessment. We keep a hazard record to record safety work, and we provide a safety case and sometimes a RAM case as well to look at the reliability before we make a change to the railways. All of this is basically in line with the RAMS life cycle. We also have method statements looking at the other side of interpretation of this question. We have method statements to show that anybody doing construction work, building things, working, digging, whatever, are doing it safely. And the method statements are there to ensure that the work is performed in a safe and controlled manner. Okay, so essentially, I try not to distinguish too much between RAM and safety when we're working on a lot of the railways, because they are so interconnected and a loss of reliability can lead to a loss of safety. Rishi?
Okay. Yeah, the next one is a quite interesting question from Rosalind Sanchez from Bombardier. Can RAMS be applied to non-electronic cars, freight cars as well? The answer is yes. We are actually doing projects in the dedicated freight corridor and also in the freight facility from the Etihad Rail. There are safety issues to start with. Even the freight cars also, if it derails, it's a hazard that need to be mitigated. Legally, you have to demonstrate that there's a safety case. There are standards of the 50126. There is one particular volume for a dedicated for the rolling stock itself that need to be fulfilled. There are routine tests and type tests. Both these type of tests for all the freight car need to be done. Then in the reliability part of it, actually, this is quite important because there are mechanical elements which can fail. And recently, going back to the safety, we come across one hazard which has occurred in one of the freight facilities in one project, where there are these trip mechanisms and all, which opens the freight car and unloads the material. That has malfunctioned and damaged the fuel tank of the diesel locomotive. So there are a lot of aspects you need to look at even for the freight cars as well. You also bear in mind you don't know what exactly the freight car would carry. It could be some hazardous material, and if it spills, it's an environmental damage as well. And if it goes through a populated area, it becomes injuries to people as well.
Yeah, Rishi, in addition to that, like in dedicated freight corridor, we are taking care that if the passenger line is running very close by, then you have to see the hazard that the accident in the freight line may cause a hazard for the passenger line.
Yeah, that's true. Yeah. Okay. The next one is what is the role of from Mr. SK Sharma? He's an independent consultant. What is the role of RAMS in present conditions in Indian Railway? Mukul is the best person to answer that. He has spent time in Indian Railway. Yeah.
Thank you, Rishi. Safety was always a parameter of importance for railways, mainline Indian railways. But the quantitative requirement we started to specify only after advent of Senelec, which was in 1997-98. However, electronic systems have been used on railways since 1987. But I mean, safety has already always been an important parameter. RAM is important because when the system fails, the control is transferred to a human operator, which may operate at a lower level. And as far as Indian Railways are concerned, you know, the RAM awareness came along with the metros when the Delhi Metro was installed. After that, we started specifying the RAM parameters, and now in all the important projects like dedicated freight corridor or train collision avoidance system, everywhere we are specifying, railways are specifying the RAM parameters to be achieved by the installer. Yes, back to, I think Maddie would like to take the next question.
Yeah. On this one, how to manage a product. Yeah.
Okay, so the question, how to manage a product which has both safety and non-safety functions. Well, obviously complex systems can do multiple functions. They do all sorts of things at the same time. Not all the functions are going to be safety critical or even safety related. But when this can actually go down not just into the hardware, where the hardware is responsible for doing different things, but in the software as well. It's important to remember that when we do safety integrity levels, these are for functions, not for the equipment or the system or the software. They are function specific. So we have to be able to separate the safety functions from the non-safety functions. And where we can't do that, we tend to have to treat the equipment or the software as being as safety critical as the highest requirement for safety, the highest SIL level within that. And there could be all sorts of problems associated simply because being talked over.
Conference tilted. Dismantling global Hindutva.
Kavita, can you please mute all and unmute?
Thank you. Right. So as I was saying, we have to try and differentiate. Where we can't, we treat everything as being fairly safety critical and with the same requirements to ensure there are no hazards and everything else. There can be problems, for example, just because you have a software computer or something doing lots of different things, you have to partition the functions so that another function which isn't safety critical can't lock up and steal the CPU time of a safety critical function and all the rest. So there is an element of being very careful and ensuring that we separate safety functions very carefully, or else treat non-separated, non-safety functions as being safety critical as well. Okay, I think I've got the next question as well.
Yeah.
What significance does RAMS hold in the modern day metro design? Well, I quickly Googled up how many people use the London Underground every day. It's about 2 million people use London Underground every day. So there's your answer. That's how critical it is. When you're talking about moving that many people, they have to be safe. They have to get somewhere on time, and you mustn't strand them underground. So it's very important. And that's true of all the major metro systems all around the world. Okay, Rishi, I'll hand you back for the next question.
Okay, so then why presently in rolling stock field prefer the OHE instead of third rail and 25 kV AC instead of 750 DC? Yeah, it's mainly because of the power distribution reasons. Because you have less losses when you have a high voltage, so the distribution is easy. Your losses are less, whereas in 750 volt DC, the losses would be more. But there are pros and cons in both of it. the stray currents would be a big issue in the 25 kV. In the AC, you need to manage it properly. Otherwise, all your assets would corrode very fast. Whereas 750 volt, you can have a negative rail and can mitigate all the stray current issues. So there are pros and cons, but nowadays they generally use AC rather than DC. Then to calculate the brake demanded by the force, yeah, this is a quite specific one. We can take this offline basically. Then the next one is on the software. Software is a systematic failures. Software errors is failure means that errors committed by the programmer, or there could be some system malfunction like stack overflow or those kind of things. The memory leakage, you may have this kind of terminology. So these are systematic issues. And it's hard to find that because these systematic issues would only be revealed when certain parameters come together. So during the design phase, it's not practical to predict reliability of a software. So you apply the 5012 standard. It's quite robust in terms of process. So have a very quality control, good quality control and a robust process is the best way to minimize the systematic defects. But when it goes into the trials and test and service, even though it is systematic failures, these systematic failures come out in a random fashion because the parameters revealing these failures appear in a random fashion. Then you can apply the reliability equations and the Duane model. There are these certain reliability growth models are there which you can apply because as far as client's point of view, if you just go and say, yeah, oh, software failures are systematic, so we don't do any prediction, we don't comply with any targets, I don't think that will wash very well with the client. As far as the client is concerned, whether the disruption happens because of hardware or software, it is a big issue for them basically. Okay, that's on the software part. Okay, then we have received some course queries, so I've selected a few. This is a certification-based training. Yes, you get a certificate, and these are accredited by this continuing professional development body, CPD UK, and some of them by the IRSC as well. So, what all departments RAM training sessions will be carried out? This I interpret it as the disciplines within the company, like the signaling, power, civils, all these kind of disciplines you mentioned. So this RAMS knowledge is required for all technical disciplines, and some basic knowledge is required for the project managers and even the contract managers, because contract consists of a lot of RAM performance requirements as well. So this has to be we conduct sessions for all these departments. So RAM training schedule from Suraj Shahi, RAMS training schedule and steps to get certification. Yeah, once you go through this online part, and there are depending upon the module or the certificate course, there are the online tests as well as some written exam or coursework. So once you do that, you get the certificate. But it can also be selective. So if you start for an advanced course and then you say that, okay, I don't want to continue for all the modules, then you can get module by certificate as well. Yeah. Yeah, I think, yeah, Mukul, maybe you can talk about RAMS as a new career, because you have changed from signaling to RAMS at some point. So maybe you can talk about that.
Yeah, RAM is definitely an exciting career, and anybody, I mean, you have to have some experience in some area, and then you can become system engineer and similarly a RAMS engineer. Maybe this one of these courses will help you in changing over to your career. Thank you.
Okay, so now we've received some queries in the chat box, so I'll just quickly we'll take some random queries on the. So one is on the EMI. I think it is a TPW system or level 1. So I think Stuart has given a good example on the TPWS itself, what the EMI issues he has faced. So yes, it applies. The answer is yes, it applies for all the electronic systems. Let's add more. Yeah. Okay. Then you have a person working on an engineering service. This I already answered that. Yes, that is. No, there is not much of mathematics as we already mentioned. Then for rolling stock and maintenance professional, I would say the RAMS certificate course would be suitable for you because that will give you an overall idea of safety and reliability as well. So that would be useful for a rolling stock professional. CPD certification, IRSC certification, yeah, it's which is more valuable. Well, it's not fair to comment on that value part of it because their thing is that they assess the course and they accredit it. So they find it that this course has all the minimum requirements these societies state. CPD is a professional body where their job is to accredit certify the courses. So they go through a detailed audit of all the courses and they give us the certificate, and we are a CPD member as well. IRSC also is their signaling association. So safety and RAM is paramount importance for them. So they encourage these training programs. So then it is certified by IRSC as well. So this will be useful to put in your CV. Actually, then it adds more value to the client. So depending upon if you're actually applying for a signaling company and if an IRSC approved course, then yeah, they would be more interested. CPD is generally interested by all the companies. Request a certain training and course which will be useful for TCMS hardware and software integration testing. Yeah, here it's more about RAM course. So either you can do the and also the requirement compliance is also important. So it's it might be useful that you do the certificate course which covers system engineering, safety, RAM and system assurance. So these modules in detail would be useful for you because testing, integration testing involves system engineering elements, assurance elements are there, then reliability and safety. So because you are providing the evidence to validate all these requirements. So it will be quite useful if you do this particular course. Mtbf and Mtt are this mean time between failures and mean time to repair. Even though it appears quite simple that between the failures, what is the time, average time spent, and also the mean time to repair, there are several detailed elements in it. It's quite important. For example, in the MTTR, there is an active repair time and also logistics delays. And within the active repair time, you got the diagnostics time, access time, then replacement and testing time, handover. So all these elements are there. So normally these are how good your design is, which will determine this active time. Then whereas the logistics is how good your maintenance strategies would determine your logistics time. So it's quite a detailed topic to cover in 1 or 2 sentences. But yes, this is in a nutshell on this. Mean time between failures is mainly one thing. I've shown you the bathtub curve, if you remember in the beginning. So it is simply when you are in the steady state, it shows that the failure rate of it. It is not that mean time between failure is not actually a design life. For simple example, in the bathtub curve, the Mtbf is the inverse of the failure rate, which is in the y-axis, whereas the design life is in the x-axis. So that's quite important aspect. Okay, so we overrun by a few minutes. Unless if you have any last minute question, we can.
I think I've just put another caveat on the question about the mathematics.
Oh, okay.
Yeah, I mean, basically, there is a lot of mathematics available, and if there was a one-to-one with a student, I could certainly provide the equations. One of the issues is if you go into the maths, usually mathematical modelling in EMC, you need to understand quite a lot about how you convert a physical model into a mathematical model. That's usually based on electronics, so you have capacitors, inductors, resistors, and you build an electronic circuit that mirrors the physical model, you solve currents and equations using Kirchhoff's law, and this is fairly serious stuff. And then you go back to the physical model after you've solved the currents and voltages and convert back to reality. So yeah, there are equations in the course. There aren't a lot of equations in the course. If you want to get involved in EMI modeling, you will need to be fairly adept at applied mathematics. Again, we can talk about that offline, because obviously I have all the equations and I develop my own equations, but we've tried to tailor the course so people understand the physics, but not necessarily have to calculate the levels of EMI involved, which is fairly difficult. But we can certainly take that offline and go into that further if you require. I think that's it, Rishi, from me.
Okay, that's good. Yeah. Okay, so if there are no other particular questions, then we can conclude, because we already overran by 15 minutes. You can conclude, Kavita.
Yeah, so Intellex and Nick Associate team, thanks to each and everyone for joining this webinar. We will share the outcome of this webinar with you all, along with the questions and answers and Intellex course details. Also, this webinar will be uploaded on YouTube and LinkedIn. The link will be shared with you further. Yeah, thank you very much.
Okay, thank you very much. Yeah.
Thank you.
And
thank you.
You can send course queries and
Thank you very much, Mr. Best.
So you can send your course queries, any other, you can by email, we are contactable. So then any particular course, then you can liaise with the Kavita, and they will be able to suggest the suitable courses for you. Thank you. Thanks.
Okay, thank you.
Thank you. Thank you so much.
Thank you all.